All right, 9-1. 9-1 uses some principles from geometry, and it starts to springboard you into trigonometry. So it's going to be a lot of fun. It's going to be very different than anything you've really dealt with before, but that's okay. We're going to take this chapter nice and slow. So I know on my calendar, for those of you who have seen it, it says we will do like 3 sections this week. We probably won't do 3 sections. We'll probably just do 2. And I want you to take your time doing all of these examples. I think for the first assignment, I linked it to 4 or 5 different Khan Academy assignments. And it's supposed to be like example 1 goes to the first video, example 2 goes to the second video, example 3 goes to the third video, etc., etc., etc. And the reason I did that is because in geometry, each of these sections would sort of be their own, each of these examples would be their own section. And so now they're just sort of throwing everything together, partly because it's supposed to be review for you guys. America has their math classes set up so that geometry is before Algebra 2. So when they come to this Algebra 2 section, it's with the expectation that you're already done with geometry, you've already passed it, you've already quote-unquote mastered it, if you will. So that's why they put everything together. Please, 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 I strongly recommend after each example going and finding the corresponding video on Khan Academy and just taking your time and getting 100 or getting an 80% for that assignment. And then once you're done, go back to the video, watch the next example, etc., etc. That way you take it just as slow as I'm hoping you'll take it that slow. And if you have any questions, you can, of course, ask me. And hopefully by this week, I will have set help class times. So if you do have issues, you can always ask me in the help class. All right, so 9-1 is the right triangle trigonometry. Again, from geometry, you guys should have remembered sine, cosine, tangent, cosecant, secant, and cotangent. All right, and so with all of these, sine, everybody knows this, SOHCAHTOA, okay? When I was a kid, we learned it as like a song. It would be like SOHCAHTOA, SOHCAHTOA. So if you have that in your head, that's great because that's what you need to use. So sine is your opposite of your theta, and theta can be anywhere. Theta can be at this end, at the sort of the acute angle, or it could be up there at the obtuse. Obtuse, of course, being greater than 90 degrees. Okay? We're going to keep this with our acute angle. So this is not in your notes, but I strongly recommend that you have it somewhere. If you have not really thought about geometry in a while, it might be helpful for you. But from theta, we are finding our opposite with that first one, sine. So our opposite of theta is, I went ahead and highlighted it yellow, and I'm just going to keep going, finding all the opposites. I'm going to highlight all of the opposites with yellow. So I don't have any opposites in cosine, but I do have opposite in tangent. So I'm going to go ahead and highlight that. All right, so I've done everything with that. Let's highlight my hypotenuse with green. Okay, so that's my word, hypotenuse. Remember, the hypotenuse is always going to be the line across from the right angle, right? So my right angle is that little box, and I went ahead and highlighted the hypotenuse across from it. So I'm going to highlight this and then this. And then if I go to tangent, I don't have any opposite because tangent is opposite over adjacent. All right, so our final one, we can make it blue. This is our adjacent, and that is the angle or the side that is attached to the theta but is not the hypotenuse. So that would be this piece down here. And again, with our tangent, we have our opposite. We have 2 angles, 2 sides touching our theta. We have our hypotenuse, but remember, our adjacent cannot be the hypotenuse. So it's going to be this angle or this side right here. So I just went ahead and highlighted all that just so you could clearly see our cosecant and secant and cotangent. That is good to know because this is just the reciprocal, or really, let me make it a little bit bigger. All right, these are our reciprocals. Okay, so it's the same connections. All right, it's the same pieces, but it is just flipped, okay? So knowing that this is the reciprocal is really important. And they can either write it like this, what I've highlighted in yellow, or they can write it like this, which I'm going to highlight in sort of a turquoise color. All right, that is the same thing, okay? So please don't misunderstand. These two items are the exact same formulas. They're just written differently, okay? But they mean the same thing, and that, again, is that they are reciprocals of the sine, cosine, and tangent. And then the other thing you need to know for this section is our Pythagorean theorem. So Pythagorean theorem, for those of you who might have forgotten, is the formula that we use only for a right triangle, okay? So you can't just like use it for any sort of triangle. It has to be a right triangle. So we have a right triangle. Our A and B are going to be our side lengths, our legs, as we call them. And then C is going to be our hypotenuse every time. And you can flip A and B anytime you want. So if you wanted to make A at the bottom, B at the top, and C across, you can. It's fine. It doesn't matter at all. It doesn't matter one bit. As long as C is across from the right triangle, you're good to go. All right, so let's go ahead and use those relationships, those ratios, to answer the example 1 questions. All right, so here in example 1.1 on the left-hand side, we have a triangle, and our two leg lengths are 5 and 12, but we don't know our hypotenuse. So we're going to use our Pythagorean theorem, a squared plus b squared equals c squared. We're going to use that, and we are going to plug in our pieces to figure out, well, what is our hypotenuse? All right, so we know that 5 squared is 25. We know that 12 squared is 144. And once we square that, we can add them up to get 169 is equal to c squared. How we get rid of our exponent, our square, is by taking the square root of both sides. All right, when you take the square root of both sides, you get 13 equals c. So our hypotenuse here is going to be 13. And it makes sense because the hypotenuse should always be the longest side, and we have 5 and 12, and so 13 is bigger than both of those, so that's good. All right, the other thing we need to notice is where our theta is. Our theta is right here. I want to highlight it a little too much. It's hard to see now, but that is our theta, so we need to think about all of our information coming from that corner. All right, so our sine, remember, sine is opposite over hypotenuse, so my opposite is across the way, that's the 12, again, over 13, that's my hypotenuse. My cosine, trying to erase this, is going to be adjacent, and remember, it's the leg that's attached to theta that is not the hypotenuse, so that'd be 5 over 13. And then tangent is opposite, which we said was 12, over adjacent, which is 5. And then again, our other relationships, our other trig ratios, are just the reciprocals of this. So my cosecant is going to be 13 over 12, and our secant is going to be 13 over 5, and our cotangent is going to be 5 over 12. Okay, so a way that I sort of remembered this from when I was in school is that I know that the reciprocals have to have one co and one non-co. So like my sine is a reciprocal with a cosecant, okay? So within that pair, one of them has a co, so I know that they are reciprocals. Some things that people sometimes get confused is they think that cosine and cosecant are reciprocals, and they're not. So think about it as with each pair, there can only be one co, which is why sine is with cosecant. Cosine is with secant. Secant can't have a co because the cosine already has the co, all right? And then the same thing with our tangent and cotangent, all right? So that is a sort of an easy way to remember what is reciprocals with what, all right? So our next piece, we have our, we're missing a leg this time. We have our hypotenuse, and we have one of our legs. So a squared plus b squared equals c squared. We're going to plug all that in. We can make 5a or b. It doesn't really matter. I'm going to put it in as b just because I want to. And I'm going to put my hypotenuse, 5 times square root of 2, in parentheses so that I remember that the whole thing is squaring. All right. If you have a Casio, this makes very light work for you. If you don't, then it's okay because I'll walk you through that process. A squared we don't know, obviously, but 5 squared is 25. All right, remember with our properties of exponents, this is sort of like a distributive property. 5 squared is 25. And the square root of 2 squared is 2. Okay, so for those of you who are forgetting how to square the square root of 2, think about it as the square root of 2 times the square root of 2. And the square root of 2 times the square root of 2 is the square root of 4. And of course, the square root of 4 equals 2. All right, so that's how we get that. All right, so this is actually going to say a squared plus 25 equals 50. We need to subtract the 25 on both sides, and we get a squared equals 25. Again, we need to take the square root of both sides because our variable is not completely alone, and we get a equals 5. So this leg right here is going to equal 5. All right, now that we have all of our pieces, I'm going to highlight my theta, and I can see that it is going to be in this corner, and I'm doing opposite, which is 5, over hypotenuse. Now here's the thing. When you have this, you have to make sure you reduce your fractions. In our previous example, we didn't really have anything to simplify, so we just sort of kept it as is. But in this one, we have a 5 in both of these, and we can cancel them out. So now my answer is 1 times the square root of 2. Well, for those of you who remember my I think it was the last chapter we did, not chapter 8 with the sequences and series, but chapter 7, when we have a square root in the denominator, we cannot keep it in the denominator. And so the work behind it, and I'm just going to write the work over here. All right, the work behind it is we need to multiply whatever is in the bottom by the top and the bottom. All right, think about this as 1. Anything over itself equals 1, right? So this is technically 1. I'm not really changing anything. So now the numerator's, just multiplying across. 1 times square root of 2 is the square root of 2. And then I come again to the square root of 2 times the square root of 2 right here at the bottom. Well, that we already figured out. It's going to be square root of 4 from here, or 2. So really, my sine of theta is going to be the square root of 2 over 2. All right, so I'm going to go ahead and box that one in since I had some work to show there. All right, cosine is going to be, again, 5 over 5 times the square root of 2. All right, that's the same thing as I had in sine, so I already did all the work for that. I'm just going to write the answer. 2 times the square root of 2, box that in. All right, and then tangent is opposite over adjacent, which is 5 over 5, which equals 1. All right. Now let's go to our reciprocals. Our reciprocals can be at any point. I could, if I wanted to, just plug it in as I see it. Technically cosecant is hypotenuse over opposite. So my hypotenuse is 5 times square root of 2 over 5. These cancel out, and my answer is the square root of 2. All right, I can do it that way. That's fine. Or I could take this and I could work it out, but really just going by the ratios and knowing the relationships is going to make your life a lot easier. So this is going to be the square root of 2. And since cosine and sine right here were the same thing, it stands to reason that cosecant and secant are also going to be the same thing. So I'm just going to say that this is also the square root of 2. Again, I could have written it out, hypotenuse over adjacent. Hypotenuse over adjacent would have been 5 times the square root of 2 over 5. And then they cancel out, giving us the square root of 2. So it doesn't really matter which way. You can look at it as each piece individually, or you can make some, not assumptions, but some conclusions about what the cosecant and secant is going to be based on sine and cosine. It doesn't really matter. I don't really care. But cotangent is our last one. That is going to be our adjacent over hypotenuse. Again, adjacent over hypotenuse is going to be 5, because adjacent is this one, and then opposite is our opposite, obviously, which equals 1. All right, so this one was a little bit weird, but it wasn't terrible. It does require some work on the other end, okay? So make sure you watch the Khan Academy. I think there are 2 Khan Academy videos for this one. There's one for just normal trig ratios, and then there is another one for our reciprocals. So go ahead and make sure you watch those, not the videos, but You could watch the videos if you wanted on Khan Academy. He does a really good job explaining all that stuff, which is why he has his own website. But really, make sure you go through and do your best on the 4 problems for these assignments. So another section that you guys learned back in geometry is about our special triangles. There are 2 special triangles that have the same relationships no matter what, if they have a specific degree, okay? And the first one is our 45, 45, 90, and basically the rule is whatever your side lengths are over on the side, they have to be the same according to the 16th postulate. And so across from the 90-degree angle, we're going to have the relationship of it being x times the square root of 2. So the nice thing about this is that, let's say they only gave us one piece. Let's say they gave us 5 as one of our side lengths. Well, because it's a 45, 45, 90 triangle, we can now figure out that the other leg is 5 and that the hypotenuse is going to be 5 times the square root of 2. All right, so that's really nice when they do that. Another way that we can find these lengths is if they give us the 90-degree angle. If they give us 12 times the square root of 2. Well, this is our x value, all right? And so that x value is our leg lengths, all right? So if we had a hypotenuse of 12 times the square root of 2, then our 45-degree across from the leg, those legs are going to be 12 as well. All right, so that is the nice relationship between the 45, 45, 90 triangle. Now, the same sort of relationship exists between a 30, 60, 90 triangle, and it is a slightly different relationship, but a relationship nonetheless. And usually when I teach this, I think about it as, you know, the outside is pretty happy because it's spacious, but the middle is a little unhappy because it's really weird. So across from our 30-degree angle, all right, we have just x, or in this case it's annotated by a, but it's just x. And then across from our 90-degree angle is going to be 2x. It's 2 times the leg length across from the 30. And then in between, or our 60, across from the 60, it's going to be x times the square root of 3. All right, so that's how I sort of remember this, and notice how our sort of 90-degree angle and our 60-degree angle right here are sort of related in the fact that they are attached to a radical. Our 45, 45, 90 has a square root of 2. I usually remember it's a square root of 2 because I have 2 45s, all right? And then our 60-degree, I think about how it's going to be the square root of 3 only because it's got a 30, a 60, and a 90, and all of those are divisible by 3. All right, so that's how I remember it. You don't have to remember that way. You could do anything you want, but it sort of helps me. So let's use that idea as we go down to example 2. All right, so for these, we are going to automatically decide, or initially figure out if it's going to be a 30, 60, 90 or a 45, 45, 90 triangle. So in our example 2.1, on the left-hand side, all right, I see I have a 60 degrees, so I know it has to be a 30, 60, 90 triangle. And from here, I'm able to incorporate some of my information. Like, I don't know what my side length value is across from my 60. I don't know what it is. But across from my 90, I see that's x, and across from my 30, I see it is 3. All right, and so the instructions say just to solve for x. So I know that x is going to equal something, and if I know the relationship between a 30 and a 90, I know that the 30, all right, is 1 unit, and the 90 is going to be 2 times that unit. So I just have to take this value and multiply it 2 times to get this. And so if you want, you can think about it as really this is 2x. So it'll be 3, all right, because 3 is equal to x, all right? So 3 times 2 is 6, and that's going to be our answer. All right, so we go to the next one, 30, 60, is the wrong, here we go, 30, 60, and 90. Again, it's x times the square root of 3, and this is going to be 2x. All right, so then I put in my information. Across from my 30 is x. I don't know what it is, but that's what I have to solve for. And across from my 90 is 12. Now remember, our 12 is 2 times x, so what it 2 times what gives me the 12? Well, 2 times 6 will give me the 12. So x is going to equal 6 this time. So it's the same thing. All right, the next one, I see a 45, so I know it's going to be 45, 45, oops. I'm expecting to have that 90 soon. All right, so 45, 45, 90. All right, so this is the one where the 45s are the same unit, they're x's, and then across from our 90 is x times the square root of 2. All right, so we plug in our pieces. Our first piece is just a side length, which is 8, and then our other side length, which is x. And because these two are exactly the same, all right, we know that our x is equal to 8. All right, so the first one isn't super difficult, but what happens if it does get a little difficult? Well, I'll show you what that's going to be in a second. 2.2a on the right-hand side, we have our two x values here. And because these are equal to each other, we know that these angle lengths also have to be equal to each other. And this is our right triangle right here. So I can see that this is going to be a 45, 45, 90 triangle. And again, I know it's a 45, 45 because our two legs are equivalent. They're equal to each other. So that means that the angles have to be equivalent, which is 45, 45. It's not going to be 30, 60 because 30 and 60 are not equal to each other. All right, so my relationship for the 90 is going to be x times the square root of 2. And it tells me that my the length across of our 90 degree or our square is going to be 4, okay? So with this one, it's a little harder to see initially, but I do know that these two things are technically equal, right? I know that the relationship is equal to x times the square root of 2, and I know that the whole length is equal to 4. So what I'm going to do is I'm actually just going to set them equal to each other as an equation, and I'm going to solve for x. So I need to divide by the square root of 2. All right, this cancels out, and so x is going to equal 4 times the square root of 2. I can't have a square root in the denominator, all right? That's something that we talked about in our previous example. So you're just going to multiply the top and the bottom by our denominator. So that's going to give us 4 times the square root of 2 over 2 times, or excuse me, square root of 2 times square root of 2 is the square root of 4, and the square root of 4 is 2. And now I can actually reduce 4 over 2. That'll give me 2 times the square root of 2. So my answer is x is going to equal 2 times the square root of 2. That's what both of these x values equal. So that one was a little bit more challenging. All right, example B, I see a 60, so I know it's going to be a 30, 60, 90 triangle. All right, my relationship between that is x times the square root of 3, and then 2x. All right, so across from the 60 is what I'm looking for. I don't know what this is. I'll just leave it blank for now. All right, and then across from my 90, I have 24. 24. All right, so to figure out what x is, so I can plug it into my relationship right here, I know that, if you want to see the math, I know that 2x is equal to 24. So if I solve for x, divided by 2, I get x equals 12. Again, you can think about it as 2 times what gives us 24? Well, it gives us 12, okay? And so that's our x value, but remember the relationship for a 60, or for the leg across from the 60-degree angle is not just x, that's a 30. It is going to be x times the square root of 3. So my answer for this, my answer is going to say x is going to equal 12 times the square root of 3, because I have to plug it into the relationship, which is x times the square root of 3. All right, last one, I see a 60 again, so I know it's going to be a 30, 60, 90 triangle. All right, so I'm going to write my relationships, 3, and then this is going to be 2x. Okay, so I do have my 60 this time. My leg length across from the 60 is going to be 12, and I'm looking for my 30. Put a little question mark here. All right, so this one is going to require me to set these two equal to each other because I need to find what is x. So I know that the 12, that's what they gave me, is equivalent to the relationship of x times the square root of 3. All right, I am going to have to divide by the square root of 3. This is the same sort of steps that I had in example A at the top with my 45, 45, 90. So I'm going to end up with x is equal to 12 times the square root of 3. I cannot have a radical in the denominator, so I'm going to go ahead and multiply the top and the bottom by that, and I should get 12 times the square root of 3 over square root of 3 times square root of 3 is the square root of 9. Square root of 9 is equal to 3. And the final thing that I can do is I can reduce. 12 divided by 3 is going to be 4 times the square root of 3. All right, so that is my answer for that. All right, so again, at this time, I strongly recommend stopping the video, going to the Khan Academy assignment and practicing that until you feel comfortable and get the grade you want. Remember, all of these grades are going to be averaged together. So if you skip one or you have a low grade for one, it's not a huge deal because it's just averaged together. But if you have multiple assignments that have zeros, it is going to, or multiple assignments that are low, that are like 50 and below, then it is going to affect your grade. So I strongly recommend you at least work until you get a 75 or higher for all of these assignments. All right, so let's move on to the next one. So example 3 is sort of the same thing as example 2. It's just another way to get your answer. So if you are really confused by the process of example 2, then ignore that and focus on example 3, because example 3 uses this table right here to sort of supplement all of our information. So for example, example 3.1a on the left-hand side says we have a 30, 60, 90 triangle. All right, we know it's a 30, 60, 90 triangle because of our, obviously our pieces. It has a 30 and a 90, so that means this piece has to be 60. All right, but it's also using our trig functions. It's using our trig functions. So what we're going to do with this particular case, and I'll show you how to use the table at the top in a second, but we're going to create the trig ratio that we had from before. So for example, I have this angle right here. So think about this as where our theta is, okay? And I have a hypotenuse, okay? And I also have an adjacent angle. So I just have to ask myself, well, what trig ratio involves an adjacent and a hypotenuse? And I should get a cosine of theta, but I know what theta is. Theta is actually 30 degrees. And it's going to be equal to adjacent over hypotenuse, or x over 8, okay? So that is the first step. The second step is going to our table and asking ourselves, well, what is cosine of 30 degrees? So I have my 30 degrees right here, and I don't need sine, I need my cosine. And so I can rewrite this as, this side can be replaced with the square root of 3 over 2 equals x over 8. All right, so again, I didn't do anything with the x over 8, I just carried it down. That relationship came from my understood theta over here, and my square root of 3 over 2 came from my table at the top. Okay, so that's all that's happening here. From here, you can actually cross multiply. All right, so this will give me 8 times the square root of 3 equals 2x. And then we're going to solve for x. So I'm going to divide by 2 on both sides, and I get x is equal to 4 times the square root of 3. All right, and so we end up with the same type of answer as we would have from our process in example 2, but we just got it with different methods. We got it with our table at the very top up here. So having this is going to be very, very helpful. Okay, so let's do one more just to solidify what we have. We have our theta over here with our 60 degrees. We have our hypotenuse again. All right, and we have our adjacent again. Okay, so it looks like we're going to have cosine of 60 degrees this time. And our adjacent over hypotenuse, that's the relationship for cosine. Adjacent is x, hypotenuse is 6, so that's going to go in the denominator. I'm going to replace my cosine of 60 degrees. So here's my 60 degrees. Again, I need my cosine. It's going to be 1/2 is equal to x over 6. Cross multiply, and you should get 6 equals 2x. Solve for x by dividing by 2, and we should get x equals 3, or 3 equals x. It doesn't matter how you write it. All right, and this is our answer. So some people like the other method better. Some people like this method better. It doesn't really matter. I'm not going to do example B's just because I think that you can use it as practice to do on your own. If you would like to see the answers, though, it is on the teacher notes. You can check your answers via that, which is a PDF that I upload on Plus Portals. All right, so at this time, make sure you are getting the grade you want for Khan Academy. I think that I combined these two examples together, so there should not be another video about it. Not another Khan Academy assignment, at least. All right, so in the next one, it's solving triangles. Find all side lengths and angles for a triangle. This is, again, a whole section in, actually I would say it's a couple of sections in geometry. So we're just reviewing it. Again, I'm going to try to make sure that everything's pretty understandable. With this one, I think I separated our assignments into two different videos for Khan Academy. So you can do it piece by piece. One is asking for the angle. Okay, so finding the angles shouldn't be difficult. If it's a right angle, we automatically know that one is going to be 90 degrees. So to find the other angle length, we can say, all right, angle B, and I'm just going to write it as B. B is understood, or capital B is understood in this book to be a point and an angle. So I'm not going to put like angle B, I don't have to. I'm just going to put B is equal to, and you can think about it as 180 because a triangle is 180 degrees, minus 90 because that that little square right there represents 90 degrees. And then the other piece we have is 28, so minus 28. And we should get that B is going to be equal to 62 degrees. All right, so that's our first one. Not difficult. And again, I think this is one Khan Academy assignment, so that should be really easy for you guys. All right, the next piece is finding the side length, okay, the side length. In this particular case, we have B, but we're missing our hypotenuse and we're missing A, okay? So let's focus on the first one. Again, our theta is going to be with whichever degree we have. We have our 28 right here, so think about theta being with that 28 degrees over here. And so you want to look at each piece and ask yourself what sort of trig ratios could we use to get this. All right, so I have my theta in this corner, as I said, and I want to find and solve for A, which is my opposite. So that automatically means I either need to use sine or tangent, because sine is going to be opposite over hypotenuse, and then tangent is going to be opposite over adjacent. Okay, if I choose sine, I have opposite over hypotenuse. I don't know my opposite and I don't know my hypotenuse. So this one's not going to work because I'm just going to end up with two variables on top of each other, two different variables on top of each other, and I won't be able to solve for anything. But if I pick tangent, so I'm going to pick tangent, all right, then I don't know what my opposite is. It's going to be A. But I do know what my adjacent is. My adjacent is 15, and so now I only have one variable to worry about, and I can solve for that. So for this one, I'm going to multiply by 15 on both sides. All right, and by multiplying by 15 on both sides, I get rid of this fraction that's sort of happening here. So it's going to say 15 times tangent of 28 is equal to A. And so now I can use my calculator. Now here's the thing, when you're using a calculator, make sure your mode is in degrees, not radians. If you do radians, it's going to give you the wrong answer, because we're not working with radians, we're working with degrees. So please make sure your mode or your settings are set so that they are in degree mode. After you plug it in, it should be about 7.98. 7.98. It's 15 times tan of 28. Should be 7.98. All right, so that is our first one. Now we need to find our final piece, which is our C, our side length C. I'm going to go ahead and separate all this. So this part over here was finding our angles, this was finding our sides, and then this is finding our last side. So this was side A, and this is side C. All right, so I have this one already. I am looking at letter C now, which is my hypotenuse. Again, I'm going to keep using B just because I know exactly what that equals. I could use A, except A is an estimate, and sometimes using estimate to get another estimate gives you the wrong answer. So anytime you have this, make sure you use whatever measurement that they give you specifically, not anything that you found and sort of rounded. All right, so for this one, I have my hypotenuse that I need, and I need my adjacent. And so that narrows it down to my cosine of 28, because that's adjacent 15, over hypotenuse. Okay. Now there's a couple of ways you could do this. You could actually, instead of doing cosine, you could do like secant of 28, because that's like the reciprocal, and you wouldn't have c on the bottom. But it doesn't really matter. You're going to end up doing the same steps anyway, so it's not a huge deal. So we're going to multiply by c on both sides, just like with our tangent, we multiplied by 15. So now this is going to say c times cosine of 28. Okay, so think about this as one complete unit. This c is not related to that c. Okay, they're unrelated. If you want, you could put an x instead of c. It doesn't really matter. But it's going to equal 15. All right, and now we need to isolate this c, right? So I'm going to divide each side by cosine of 28. Cosine of 28. So this cancels with this, and I'm just left with a c, or the side length c on the left-hand side, and then it's going to equal 15 over cosine of 28, right? Just remember that when you type this in your calculator, 28 has to be in the degree mode. Once you set it up once, you should be good to go from there. But if you multiply this, it's going to give us 16.99 approximately. Approximately 16.99. All right, so that is our answer for all of this. If you wanted to, if we had room, I would ask you to like label everything, but you really don't have to. If you wanted to, you could fill it in over here, you know. So we could say B is 62 degrees, A is approximately 7.98, and C is approximately 16.99. So if you wanted to put it on the triangle, you can. Again, it's not a huge deal. All right, so let's do example 4.1. Same process again, and I'm actually going to draw my triangle to be sort of the same way as before. Remember, C is always going to be across from our right angle, so I know automatically that's going to be C. And then from here, it doesn't matter if A is here and B is there. It doesn't really matter. Oops, that's wrong. The length has to be across from the angle A, so that's why A is moved over to the right, and then B is going to be at the bottom. Again, if you want to flip it, it's okay. It's not a huge deal. It doesn't really mean anything. All right, we are given B, which is 45. So that means that A, all right, so A is automatically 45, right? Because 1 is 90 degrees, 180 minus 90 minus 45 is going to give us 45. So this is actually one of our special triangles. If we wanted to, we could just use the same idea or use the concepts that we learned before, and we can apply it, or we can just ignore all that and just do our like tangent or our trig ratios if we want. So for sake of following our trig ratios, I am going to do it like that. All right, so our other piece is that C is going to be equal to 5. All right, so think about our theta being either A or B. It doesn't really matter. I'm going to keep it at A just to make my life happier. All right, so I need to find A, which is opposite, and then the only other piece that I have is my hypotenuse. So my thing is going to say sine of 45 equals opposite A over our hypotenuse, which is 5. All right, so this is going to equal, to get rid of it, I need to multiply each side by 5. So A is going to equal to 5 times sine of 45. If I type that into my calculator, A is going to equal about 3.54, okay? And instead of me doing extra work, I'm actually going to use the concepts I know, which is I know that A and B are equivalent, all right? That's what I know from a 45, 45, 90 triangle. So I found one, so automatically I know that the other one is also going to be equal to 3.54, approximately 3.54. And that is our answer. All right, so let's do one more. Since this one was like sort of straightforward, we're going to do another one just to make sure we understand. All right, and I'm going to flip my A and B this time. So this is C. I'll put A on the top and then B on the side this time. All right, our pieces of information that they gave us was that A is 32 degrees and B is equal to 10. All right, so from that we can do and find our information about B. B is going to be 180 minus 90 minus 32. So therefore, B is going to equal 58 degrees. 58 degrees. All right, now we can spend the rest of our time finding our other pieces. So I'm going to put a 58 degrees here. We'll put theta up here with A, with our 32 degrees. All right, and we will find our, let's find our hypotenuse first. So that'll be our adjacent and our hypotenuse. So that's our cosine of 32 is equal to adjacent, which is 10 over C. Multiply by that C on both sides, we get C times cosine of 32 is equal to 10. Divide by cosine of 32 on both sides. We get C is equal to, or C is approximately, if we type that in the calculator, 11.79. 79, not 97. Okay. All right, and then finally we can find our final piece, which is our A. It's our opposite, and I want to use my adjacent, our adjacent as well. So I'm going to say tangent of 32 is equal to our opposite A over our adjacent, which is 10. Multiply by 10 on both sides. This cancels out. I get A is equal to 10 tangent of 32, which if I type in my calculator gives me approximately 6.25. 6.25. So this is going to be 6.25. All right, and now we have completed our triangle. All right, the last couple of problems has no Khan Academy assignment, and I'm not going to do both of them. I'm just going to do, I'm not going to do all three. I'm going to do 2 out of 3, just so that you can sort of understand what we're doing here. But again, all the answers are online if you want to check out my notes that I post. So let's go ahead and just jump right in. It says you are hiking near a canyon while standing at A, and you measure an angle of 90 degrees between B and C as shown. So it goes ahead and gives you this picture, and I'm just going to sort of highlight that right angle between, at angle A this time. All right, it says you walked to point B, and you measure an angle of 76 between A and C, and the distance between A and B is about 2 miles. How wide is the canyon between A and C? All right, so I'm going to go ahead and just highlight that. We're just looking at this piece right here, so I'm going to say that this is our X piece. This is what we're looking for. All right, and since we do have a degree at 76, I'm going to put my theta over here. And so I can see that this is actually going to be my opposite, and then I am attached to my adjacent. Adjacent. All right, so I have my opposite and my adjacent, and I don't have my hypotenuse involved at all this time. So now I can set up my formula pretty easily. I'm going to say it's tangent of the angle, which is 76, is equivalent to the opposite, x, over adjacent, which is 2. And now it's just solving for x. So x is going to equal 2 tan of 76, which is approximately 8.02 miles. So it's the same thing as we did before. It's just applying it to a real life example, which is very, very useful. I typically round to 2 decimal places, and just make sure you have your units when you come to problems like this. All right, so let's look at example 5.2. 5.2 says a parasailer is attached to a boat with a rope 72 feet long, and the angle of elevation from the boat to the parasailer is 28 degrees. Estimate the parasailer's height above the boat. All right, with this one, it's always better if you have a picture. So like in our previous example, they had the picture drawn for us, but now they don't. So you don't have to get super fancy, but I just go ahead and draw the whole thing just because it helps me with life. So here's my boat. We're going to ignore that the only boats that I can draw are sailboats, and sailboats don't usually get to the type of speed that we need, so we're just going to ignore that. But here we are up in the air with our little parasail. There we are. And we are connected with a rope. They say that the rope is 72 feet long. So I'm just going to attach that. And it's asking, what is the height above the boat? All right, so really I need to find the height right here. So think about this as my sort of right angle. All right. And the other thing is that it tells me that this angle over here is supposedly 28 degrees. All right, so that's where our degrees are. We are finding our opposite, and we have our hypotenuse. So think about this as theta. We have our opposite and our hypotenuse, and that means that we need to use our sine. Okay, so this will be sine of 28 is equal to, I don't know what my opposite, my h is, so I'll just put h, or you can put x, doesn't matter, over my hypotenuse, which is 72. Solve for h, so multiply each side by that 72. So it should say h is equal to 72 times sine of 28, which is approximately 33.8 feet. All right, so how far are we above this boat? We are approximately 33.8 feet above the boat. And yeah, so go ahead and try example 5.1, which is on the left-hand side on your own. Again, draw a picture to sort of help you, but it's the same process as we've been doing. And check your answer with my answer key that I post on Plus Portals. All right, so hopefully if you have any questions, you can come ask me about that, and I look forward to your questions.